Once again, afternoon, folks. This time around, I have three sets of questions on momentum. These are typical exam questions which show applications of the effects of momentum on problem solving. And if you look, sometimes they are integrated on objects on inclined plane. Let's have a look at the information given. The diagram shows two particles, P and Q, which lie on a line of greatest slope of a plane ABC. Particles P and Q are each of mass m, and the plane is inclined at an angle I degrees to the horizontal, where sine I is 0.6. So the length of AB is 0.75 meters and length of BC is 3.25 meters. Now the section AB of the plane is smooth and section BC is rough. The coefficient of friction between each particle and the section BC is 0.25. Particle P is released from rest at A, and at the same instant, particle Q is released from rest at point B. So let's try and digest the information given. We are told that this section here is smooth, so in other words, our mu is equal to 0. But here is rough, meaning there's going to be a friction where the coefficient is 0.25. I'm told both objects are of m kilograms, implying when we are looking at weight, here we'll get each 10m and there 10m, because it's g times whichever mass value will be having. We also told information that both objects are released from rest, implying the initial velocity for both objects is going to be equal to 0. Then proceeding with this, let's check what we are required to find. We asked to verify that P reaches B at 0.5 seconds after the time at which it's released with speed 3 meters per second. In other words, in this question, we are required to find V given, well, we have time there, verified that the particle P reaches B 0.5 seconds after it has been released. In other words, we are, well, with a speed 3 meters per second. So we want to verify that the time that it takes for A to move from its starting point to the end, it's 0.5 seconds, and also confirm that the final speed is going to be 3 meters per second. Then what do? Let's come back to the question here. We have U, which is 0, but remember we also have S. I think the only thing missing is acceleration. And for us to get acceleration, we will need to bring Newton's second law. Let's check what Newton's second law says. It says F net equal to ma. But remember the net force, this section AB, it is smooth, so we are going to be interested in the weight component only. So as I move up, it means I'm interested in this component when I break these two into components. I want this component which corresponds to what we have there, which is W sine theta. But remember, we're told sine I is equal to 0.6. So the manner in which we treat this problem is, we know it's a right angle triangle where this is I degrees, and we'll convert this to its equivalent fraction, which is 6/10. But when we simplify, it's actually 3/5. And we know sine is opposite side over hypotenuse. And when we think like that, we know this is 3, this is 5, implying the adjacent side is going to be 4. So what do we do with this? We are now going to say, but when we say W sine theta, but because this plane is smooth, we don't have friction. So that's the only driving force that we have. And our W, we said, is 10m. So we can say 10m sine theta. But sine theta, we are told, or in fact, we saw that is 3/5. So I can come down and say F net, which is W sine theta, or sine I for this case. Let's put the proper variable. Sine I will be equal to mass, but mass is m times acceleration A. So our weight, we saw that is 10m, and sine I, we said, is 3/5 equal to ma. Our interest is to find A, but there are m's both sides, so they're going to cancel. And when we check carefully, our acceleration is going to be 6 meters per second squared. Now I've got acceleration, and I know my initial speed u is 0, and s, the distance, is given as, I'm sure it's 0.75. Let me double check on my shape. Yes, 0.75. So what's my interest? My interest might be to find, well, it can be, we can start with t. So if we want t, we are simply saying S from our equations of motion is equal to ut plus half a t squared. And S is known, is 0.75 equal to u, but initially it was 0, so this whole part gives us a 0, times a half multiplied by acceleration, we said is 6, multiplied by t squared. So when I simplify here, there I get a 3, I divide both sides by 3. So in essence, t squared is equal to 0.25. Therefore, our t, which is root of 0.25, is going to be 0.5 seconds. Now that I've got a, t, and u, I can bring in the first equation of motion, which says v equal to u plus at. Because I'm interested in the final velocity, which is there, I want to confirm, because initially it was 0 plus acceleration, we said is 6 multiplied by the time, which we said is 0.5. So when I do my simplification, v will actually give me 3 meters per second. So I've shown what was required on their first problem. Now find the time that it takes from the instant the two particles are released until they collide. So until they collide. In other words, when they collide, that's after 0.5 seconds, they will have covered the same distance. So what do we know? We know that if we come back to our shape, let me change my color to green, and we discuss. We come to our shape, we know that at this point, the final speed of object P is going to be 3 meters per second. But remember, in this section, which is rough, whatever value of acceleration that we have, it will apply to both P and Q, because they are of the same mass. But now, in this section, this value, which was V, it becomes U for this particular section. And moving from this section in between, it means these two particles, they'll be differing with 0.5 seconds that we confirmed. So whatever we do, if we want them to meet after covering the same distance, maybe h, for instance, it means both particles will have moved. First particle p from this section we have moved t seconds, but particle b, because we'll be counting after 5 seconds for p to reach this point. So for particle q, it will be t plus 0.5. So let's check. We might try with particle q to say if we want to find the magnitude of acceleration, how do we go about it? We know for this scenario that it's rough, there we have mu. So we can say, let's go down into our calculation. We are going to say particle Q, its mass is m, but remember, if we want friction, it's mu r. So mu, we agreed, is 0.25 multiplied by, remember, r, it comes from the normal, which is w cos theta, but w was 10m multiplied by cos I. But cos I, if we look at our shape, the red one, cos is adjacent over hypotenuse, which is going to give us 4 over 5. So if we say 4 over 5 for cos theta, I'm sure here we are going to say W cos, but cos we are saying is 4 over 5. So this is our total friction. So according to Newton's second law, for the section where it's rough, we are going to say F net, but F net comes from the weight component, which we started by saying is W sine theta. So W, that was 10m multiplied by sine theta, was 3 over 5 minus the frictional force, which is 0.25, yes, a quarter. But remember, there's a 4 and 4. It looks like it simplifies to 2m, being equal to mass multiplied by acceleration. And when I try to do my simplifications, Here I'll get 5 into 10, that's 2 times 3, 6 minus 2. So it ends up giving me my acceleration being 4 meters per second squared. Now that I've got acceleration, our interest is on what happens to the distance covered. Because for them to meet, they'll have covered the same distance as well as the time when it happens, it should be exactly the same time. But because one is ahead in terms of time, we can then come to say um, that's the new equations we are going to build. We are going to do two equations for P and for Q. Let's start with particle P, because P's initial speed during the frictional section is going to be 3, and its acceleration we are given as 4, and the time that it takes is actually t seconds, and the distance to be covered, it will be the same. So we can say S will be S. Then when we come to Q, the initial speed when it started to move, it was 0, and it experienced the same acceleration, which was 4. Then the time where they meet is going to be t plus 0.5, because we have covered 0.5 seconds before P reaches the rough surface. Then S will be S. Then let's try and have a look at which equations we can use to find the respective time. Let's see if we have some space. Yeah, we do have. My interest was to use the equation S equal to ut plus half at squared. And when I substitute my S, I don't know it, but the initial speed is 3 multiplied by the time t, which we are saying it will be the same, plus half a, the acceleration we got it is 4 multiplied by t squared. So this is what's applying to P. And when we come to Q, using the same equation, we are going to say our S, which is the distance to be covered, is ut, but remember there's a 0 there, so it goes or it cancels. Then we just have a half into A, our acceleration 4, then into the time, which will be t plus 0.5 squared. So let's proceed with our calculation. Now we are allowed to combine the left and the right because they both are equal to S. So we can choose to say 3t plus, when I simplify here, it gives me 2t squared. But this side, when I equate, because we're saying it's equal to the same, I'll have 2 outside the brackets. Inside I'll have t plus 0.5 squared. And when I do my expansion there, it's going to be 3t plus 2t squared equal to, this is 2 into, it's going to give us t squared. And when I combine this, I get t, and there I'll get plus 0.25 when I square 0.5. Then next it will be 3t plus 2t squared equal to, when I expand the brackets, is 2t squared, and there I get 2t, and there I get plus 0.5. And if we check clearly, this will cancel because it's appearing both on the left and right hand side. So I'll end up having 3t and 2t. So when I collect them together, I mean, it will give me my time as time t equal to, that's when I transpose this, is equal to 0.5 seconds. So what it implies is it takes 0.5 seconds from the instant the two particles are released until they collide. No, it's from the instant when both are within the rough surface. But when we say from when they are released, we are going to look at the time taken by particle Q, because Q was the one which started 5 seconds within that rough section. So in other words, the total time T in essence is going to be 0.5 plus 0.5, which will give us actually 1 second. Let's move on. Two particles coalesce when they collide. The coefficient of friction between the combined particle and the plane is still 0.25. Find the time that it takes from the instant the particles collide until the combined particle reaches C. So the first thing of interest is after how long do they coalesce? That's what we want to find out. So for particle Q, they coalesce after a second. So particle Q, what we know is initially it was 0, A, it was 4, and what else do we have? The time that it traveled, it was 1 second. So what's our interest? Our interest is to find S, or distance. So if we want S, I'm sure it's UT plus half AT squared. So UT plus half AT squared. Obviously, S covered there. This part is going to be 0 because everything is 0. They multiplied by 4, multiplied by t squared, which is 1 squared. So when we simplify, the distance covered before they collide, it was 2 meters, sorry. And if we come back to the top part, we can see that within that section, the total distance BC where it's rough is 3.25. So when they coalesce, they move for 3.25 minus 2, which is 1.25. So the distance covered when they coalesce is going to be 3.25 minus 2, giving us 1.25 meters. Then what do? We want to know first the final speed of both P and Q before they coalesce or they meet. So if we want final speed, because we know within that section they covered 1.25. So what will be happening here is we are going to say, let's say V for particle P. But remember, this particle P, initially in that section, it had a speed of 3, and the distance for them to collide, it was that one there. But if we want, we can just take the acceleration within the region is 4, and the time, but the time is not 1 second. The time for P is actually 0.5 for them to meet. So from the first law, we can say U plus AT. So we are interested in V. So this is 3 plus A, acceleration is 4, multiplied by T is 0.5. So this will result in a speed of 5 meters per second. Let's try VQ, the final velocity for Q. But remember, for Q, we will use the same equation, U plus AT. And for Q, because it started from rest, the speed is 0, plus acceleration was also 4, but the time for Q is 1. And when we simplify, it means for Q, the speed is going to be 4 meters per second. So these are the speeds before they collide. So what are we going to do with this? We now say, according to momentum, we are saying this particle P with a speed of 5 meters per second, it collides with particle Q with a speed of 4 meters per second. So after coalition, they are combined and they coalesce, so they are now moving together. So our interest is to find the new speed, but their masses are both m, so this time it will be 2m. So from conservation of momentum, we are saying we have got 5m plus 4m equal to 2m. And when we simplify, well, it's 2m times v. Well, here there's v. So 2m, that's the combined mass. Then we end up having 9 being equal to 2v. And as we proceed, we are saying we divide both sides by 2. Therefore, as a coalesce component, we have 4 meters per second. That is the initial speed with which they start. So we can say as a combined system, they are moving at an initial speed of 4.5 meter per second. But what's our interest? This time around, we are now interested in acceleration. Is it the same acceleration or is new acceleration? Fine, we have got S. S is 1.25 meters. So if we can find A, maybe we can then find the final velocity. So let's try and have a look at A. Remember A, if we are to go up, I'm going to change my color up to say, when they coalesce, because it's the frictional region, So let me try and bring a black color to say when they coalesce within this region, we are saying we are going to have the driving force as 2m, but the weight is going to be 20m sine I, but remember sine I gave us 3 over 5 minus the frictional part, which was mu r, because we are told the friction is still the same, so it's 0.25 multiplied by r. The normal force is still going to be 20m cos, but cos was 4 over 5, will be equal to 2m multiplied by acceleration. So the m's, they can cancel, but when I simplify the 5 into 20, that's 4. So this will generally give me 12 minus, now there I've got a quarter, so that will be a 4 being equal to 2a. So quarter, 4, 2a. So it looks like my m is equal to 4. Looks like there was no change in acceleration. So we can go down to say, let's have a look. We have an acceleration of 4. So if my acceleration is 4, then I'll then say my interest is on v. Let's check the question. Oh, find the time it takes from the instant. So I'm interested in t, not v. So I've got those. If I want t, let's see, t, not v, t. So I can use the equation s equal to. So it's 1.25 equal to ut, that's 4.5 multiplied by time. So that's ut plus half a, the acceleration we are saying is 4 multiplied by t squared. And when I do my simplifications, let's check. I can choose to multiply throughout by 2. Well, half t. Well, I can divide throughout by 2. So, because they do give me a 2. So if I divide throughout by 2, it will give us t squared plus 2.25 t minus 0.7, or let's see, 1.25 divided by 2, 0.6, 0.5 equal to 0. To see if we can find the value of t. We are going to say that t is equal to minus 2.25 5 all over 2. Then I'll bring my calculator and try and simplify the calculations. I'm going to say, well, because time cannot be negative, I'm expecting to get a positive from the plus. So let's say root of 2.25 squared plus 4 times 0.625. Then if I get out of the root, what do I get? It looks like it gives me 2.75. So from 2.75, if I say minus 2.25, it will give me half. And when I divide half by 2, the result is quarter. So it looks like the time to be taken there is going to be 0.25. So time taken t is going to be 0.25 seconds. I hope you found this interesting. It was lengthy, but those are all calculations we get from typical questions to do with momentum. Thank you.